Hi folks, it's Ron with Ideal. In this video, I'll step you through every feature and function of the 61-347 digital multimeter here from Ideal. Now folks, when you first purchase the tester, you'll see that it does come with a carrying case that you can store it in. It also has what they call a certificate of conformance, and all of Ideal testers come with this certificate, which means that the tester was tested during manufacturing and that it meets or exceeds the published accuracy specifications for the tester. It also has the serial number on the tester, and that serial number is also on the back of the tester here, so if you ever have any warranty issues or problems, you hang on to this little blue card for that. You also get an instruction manual with the tester, and please read and fully understand the manual before you actually go out and use the tester. You also will get a set of test sleeves to make your measurements, as well as a K-type thermocouple to make temperature measurements. Now, before we get started on this tester, I want to show you a few basic things here to start with. One is that the tester is a true RMS tester, so it will give you more accurate voltage and current readings in AC circuits, and especially if you're in commercial environments where harmonics may be distorting that AC waveform, so true RMS is always nice to have. It's also IP52 rated, which means it's moisture and dust resistant, and it can sustain a drop from 6.6 feet or 2 meters. You also see on the testers on the inputs here, it says that it's a Cat 3 tester up to 1,000 volt in the Cat 3 testing environments, and up to 600 volts in Cat 4 testing environments. And we can test AC and DC amperage up to 10 amps with the tester. Now, before we get going, we're going to turn around and show you the back of the tester. Right here on the back of the tester, it has some certifications from UL, so it's both certified in both Canada and the United States. CE is a European standard, and the little triangle there is for Australian. So several testing laboratories have looked at these testers, so you know that they are what we say they are. The fuses are also listed right here if you ever blow a fuse and have to replace that. And you'll notice also that in the back of the tester are probe holders to store your probes when you're not needing them or using them. You can also store them in the upper position on the back of the tester. You'll notice in the middle of the back of the tester here is a mount for a cable hanging strap, I should say, that can be attached to the tester so you can hang it from a nail, screw, or magnetic surface, because these are magnetic, and the hanging strap is sold separately. You'll also notice the tester has kind of a kickstand on the back of it, so we can stand the tester up during our testing if you want to. And I'm going to go ahead and remove that kickstand so we can get to the back of the tester and the battery compartment in the back here. And there's 4 screws that hold the battery compartment cover, and I've already listed 2 of those. And I'll go ahead and remove this, folks. And I would warn you that if you remove the back of the tester, don't try to actually use the tester to make any measurements. Always replace that cover. Well, maybe I didn't get that screw. Make sure you replace this cover if you're actually doing testing. You know, you see in the back of the tester there are 3 AAA batteries, I should say. And the tester does have an orientation legend inside the battery compartment that tells you which way to put the positive and negative batteries, so make sure you install them properly. Here are the 2 fuses, and again, if you ever need to replace the fuses, make sure you replace it with the proper fuse. The small one is for milliamps and microamps. The big one's for up to amps. And I'm going to go ahead and remove this smaller one and show you some neat features of these new line of testers from Ideal. And I'm going to go ahead and turn the tester over here to amperage, specifically milliamps. And you'll see that it's giving me a lead warning, letting me know that the red lead is either not in the tester or it's in the wrong port. And you'll notice if I go over here where it's volts and of resistance, I still get the lead warning. Go to amps, I still get the lead warning, but because I'm in milliamps, it's wanting me to put the lead right there. And you'll notice that again, the lead warning has gone away, but now we have the fuse warning, letting us know that again, the fuse is either missing or it's been blown. And as I said before, always make sure you replace those with the proper fuse. And I'm going to go ahead and put the cover back on so we can actually make some measurements. All right. I'm going to go ahead and turn the tester 2 volts. And one of the things I'll point out to you that comes up on the display right away is something called APO, and that stands for Auto Power Off. And if you ever wanted to defeat that feature, say you're trying to find out what a temperature change is on a device over a period of time, and you want to know what the max or lowest temperature is, we can defeat Auto Power Off by hitting the select button once, turning the tester back on to any function, and you'll see that the Auto Power Off feature has now been disabled. And to re-enable it, just turn it off, turn it back on, and it re-enables that Auto Power Off feature. Now you'll notice that the tester, as I have it plugged into, the test leads plugged into it, I should point out to you here that on these test leads, you'll notice that I have removed these protective caps. Anytime you remove the protective caps, always make sure you replace them, because with the protective caps removed, you're limited to a Cat 2 environment. You can no longer safely use the tester in a Cat 3 or a Cat 4 testing environment because you've exposed these metal tips. So always replace those plastic caps. Now you'll see the tester is giving us this very small reading in volts. Here it defaults to AC volts, and it's reading millivolts in about around 70 millivolts, and it's fluctuating. And the reason that is the test leads essentially are acting like antennas, and they are picking up electrical energy being radiated from different electrical sources like the wiring in the walls, a TV, the extension cords on this bench top. All those are reading some electrical noise. And if you'll notice, if I touch the test leads together, the meter does zero out, and we no longer see that electrical noise. Now I'm going to go ahead and plug it into a power supply I have plugged in over here. And we'll plug it into the power supply. And the tester is giving us about 315 millivolts, and you'll see we have 1 extra digit of resolution there. The 6,000 count display, what that means is the resolution on the display will change at 600 millivolts, 6 volts, 60 volts, and 600 volts. And you'll notice as I ramp up the power supply past 600 millivolts, that decimal point will change on us, and sure it did. Now we're over the 600 millivolts, and our decimal point has been moved over to here, but we're still reading down into thousandths of a volt. Now it'll change again as I crank up past 6 volts, and now we're a little past 6 volts. You'll see the resolution has changed again, and we're reading into hundredths of a volt. And one of the nice features of these new line of testers from Ideal is that as you get above 30 volts, the tester is going to give you an audible tone, which you just heard a minute ago, plus it gives you this red LED, and you also see the lightning bolt in the display. This is a warning that you're above a 30 volts, and depending on your testing environment, whether you're in a Cat 3 or a Cat 4 testing environment, the use of personal protective equipment might be advisable for you to be wearing, and anytime you're working with electrical equipment, following good industry safety guidelines is always a good idea. So that's just a high voltage warning is what that is. Now, as I ramp up past 60 volts, you'll see the display, the resolution will just change again in the display. And we're reading now down to a tenth of a volt. Now this power supply I have will not go up to 600 volts, but I will ramp it up to 100 volts and show you some other nice features of this digital multimeter. So now we're at about 100 volts, and one of the nice features on the tester is this relative or delta function on the tester. This allows us to measure the differences between two readings. And you can use the relative function on AC and DC voltage and current, capacitance, temperature, and resistance. So if I hit the delta button once, it basically stored the 100 volts we were just reading a moment ago. And I'm going to apply another 20 volts to the power supply. And it's, again, giving us the difference between that 100 volts and the 20 volts I'm now reading. So, and I can disable that again, and you'll see that the tester is about 120 volts. So again, you can use that relative function to compare two different readings. The range function here, you'll see that it says auto there, so it automatically goes into auto ranging. But if I hit the button once, it disables auto ranging. and it has the tester in the proper range, which is at 600 volts. It gives us this 120 volt reading. If I hit the range button once, it goes to the next highest range, which is up to 1,000 volts, which is why you get the 0 in the display over here. And if I hit the range button one more time, it goes to the smallest range the tester has, which is down in the millivolts, and obviously millivolts is much smaller than the 120 volts the tester is actually reading, and it gives you the OL or over limit. The next range is to 6 volts, which again is much lower than the 120 volts we're actually reading. 60 volts is the next range, so we still get that same indication in the display. And finally, we're back into the 600 volt range and we get the proper range again. And again, I can re-enable range by simply holding down. It goes back into auto ranging. And again, auto ranging can be used on AC and DC voltage and current and resistance. The next function over here is min-max. If I hit the max button here, the tester is going to maintain the highest reading it sees. So I'm going to crank up the power supply a little bit, and again, it's maintaining the max reading it sees. If I hit the button once more, it goes into the min that it saw a minute ago, and if I turn the tester down, it'll again hang on to the smallest value that it's reading. And if I hit it again more time, you can see it's back up to 125 degrees, or 25 volts. And the min-max can be used on AC and DC voltage and current, temperature, and resistance. And to turn it off, I'll just push the button down and hold it down. Now the hold button allows us to hold a reading. So you see the H in the display, and if I disconnect the tester from the power supply, sure enough, it's held on to the reading that it saw, the last reading that it saw. And the hold function can be used on any of the different functions, whether we're measuring resistance or current or whatever it might be. Now I'm going to go ahead and plug the tester back into the power supply and show you while we're here some other functions here, and that is frequency and duty cycle. You'll see that the display has HZ in it, indicating your reading frequency of the AC waveform, which we would expect it to be right around 60 hertz, and it is. We can also measure duty cycle by pushing the select button once. You'll see the percent symbol come into display, and you would expect the duty cycle on an AC waveform to be roughly 50%, which it is. And we can measure frequency from 10 hertz up to 10,000 hertz, and duty cycles from 0.1% up to 99.9%. All right, I'm going to switch this back to voltage. Now I have a little test board here that I can use to demonstrate some of the other features of the tester. And we're going to go ahead and measure DC voltage by pushing the select button. Once you'll see DC comes up in the display. And from going from this common port to the voltage port on this testing board, we're reading that the two AAA 1.5 volt batteries wired in series are putting out right around 3 volts, which is what you would expect it to be putting out. Now the next function on the display, we get into continuity, resistance, and diodes. And you'll notice that in the display right here is a little audible symbol indicating we're in the continuity setting. If I touch the test leads together, you'll see the meter basically zeroes out, the red LED lights up, and you get the audible tone indicating you have continuity. And we can check the continuity of motor windings and switches and a variety of fuses and different devices out there. Now, the continuity, if you're in continuity and you get under 10 ohms, that's when you'll get the meter to beep at you. I happen to have 4 resistors wired in series or parallel on this board, which is a little under 6 ohms. So if I happen to be in continuity, it'll read that I have, again, a little under 6 ohms, but because of the fact that it's under 10 ohms, I'll also get that audible indication as well. So if I hit the select button once, it puts us into the resistance, and I can go across those same 4 resistors and still get that same reading. But again, I no longer get the audible tone. So again, continuity under 10 ohms or less. And if you're in resistance, you will not get the tone. Here's those same 4 resistors wired in series. You'll notice the display went to 0.700, and then above it says kilo ohms, or 0.7 kilo ohms, which is basically 700 ohms, because of the 600 count resolution in the display changed. Here's a single resistor at 375 ohms, which is under the 600 ohms when the resolution of the display would change on us. Another feature is to measure diodes, and there's a diode symbol in the display, and there's one on this board. And a diode is a device that will let voltage flow through it in only one direction only. You'll see we're picking up a little over half a volt there. If I reverse my test leads, you'll notice I get no reading at all. So a diode is good if it's giving you a voltage indication in one direction only, which it is. The next thing on the dial is for capacitance. And we have a small capacitor on the board. If I touch the common port and the capacitor port here, we'll get a reading, and it's reading about a little over 9. You'll notice at the top of the display it says microfarads, and this is, I believe, a 10 microfarad capacitor, so that capacitor is good. And if we want to move over and start measuring things like temperature, we'll have to remove the test leads from the tester and install the K-type thermocouple that the tester comes with. The K-type thermocouple has a positive and negative. Just make sure you put the positive in the red hook port. And sure enough, we're picking up the ambient temperature here in the room, which is around 73 degrees. You notice if I touch the very tip of the thermocouple, the temperature starts to rise. And we can measure temperature from -40 to a little over 1800 degrees Fahrenheit. And of course, we could switch this to Celsius if you care to. Now, next thing I'll show you is the current, DC current, using the test board. I'll plug black into that port, and I'm going to measure milliamps here. So you'll notice it's giving us lead warning and let us know that we're in temperature, but we have the probe in the wrong port. And when we move to milliamps, we don't longer get the lead warning, and we don't get the fuse warning, which means the fuse is good as well. There's a little LED on this board. So if I go across that and make the tester part of the circuit, the tester basically is powering that little LED, and we're pulling a little under 11 milliamps of DC current. And this same board is a resistor wired in series with that LED, and you'll notice that the intensity of the light has gone down, and we're reading a little under 3 milliamps of DC current here. But again, we can measure DC or AC currents up to 10 amps with the tester. Now, I should tell you that if you're in the microamp setting, you can leave the tester part of the circuit for up to 10 minutes. In milliamp circuits, where you can leave the tester part of the circuit up to 10 seconds, or 1 minute, I should say. And then amperage, you can leave the tester part of the circuit up to 10 seconds before you might potentially burn out a fuse on the tester. Now, the very last thing I'll show you on the tester is the non-contact voltage capabilities of the tester. Now, you'll notice that we're in EF. Right at the very tip of in the middle here is a sensor for non-contact voltage sensing. Now, you'll notice that as I pass this extension cord down this across the tester, you'll see that it is picking up the hot conductor in that extension cord. And we can pick up voltages between 40 volts up to 600 volts with the tester. But I'll warn you that the testers don't quite work like you would expect out of one of these different little voltage sticks here. You'll notice that if I hold the very tip of the tester up against this triple tap, we are not getting or sensing any sort of a voltage here. It's due to the fact that the insulation around the top of the tester and the insulation around this voltage triple tap is preventing that. Where these little voltage sticks actually have the voltage sensor right here on the very tip that can be inserted into an outlet to pick up, again, a hot conductor. So again, these don't quite work like you would expect a voltage stick to work. However, you could, utilizing the red lead, stick the red lead into the outlet, and you'll notice that we do get an indication on the hot. We're not getting an indication on the neutral, and we're not getting an indication on the ground, only on the hot conductor in that triple tap. So there you have it, folks. That's the ideal 61-347. As I said earlier, please read and fully understand the manual before you actually go out and use the tester. Hey, I'm Ron with Ideal. I'll see you on the next one.